Some of you may know 0x before, but I'm going to give you a bit of an intro after we get through the disclaimers. I'm not here to pump my bags. Everything in this presentation is an approximation of the truth because I didn't have enough time to put the entire truth in here. And I'm not going to give you any alpha on how 0x's aggregation router works. You're going to have to build that yourself. What is DEX aggregation? Hopefully you already know, but we're going to talk about it anyways. You're going to get the best price for your swap by using more than one DEX brand. So, for example, I want to dump my Chill Guy bags, but I want to dump it to USDC. Radium probably has a good price for Chill Guy wrapped SOL, but I wanted USDC, and Meteor maybe has the best wrapped SOL to USDC price. We're going to have to do what we call a multi-hop to get you that price. Take the output of one DEX, put it into the next DEX. Likewise, if I've got a really big SOL bag and I've decided I want to dump that, no single DEX is going to give me a good enough price at 100 SOL depth. So I'm going to need to break that order up, split it amongst a bunch of DEXs, and we call that multiplex. DEX aggregation is the problem of intelligently combining multi-hop and multiplex in a variety of different ways to get you the taker best price. The DEX aggregation business is the idea that while DEXs themselves know how to price and attract liquidity, actually taking good advantage of that liquidity requires another specialized skill set, and that's the job of a DEX aggregator. You might think it's complicated. Good, you should use our product. Your users also don't want to think about this. They don't want to think about which DEX is going to have the best price for which token. You should use the DEX aggregation API to figure that out, get the best price every time, and you don't have to think about the complexity of encoding instructions for your swap. So why is DEX aggregation hard? This is a real swap that one of our users did in Ethereum. There's 28 legs in this. That's a lot of legs. And this was the best price at the time. This, of course, was a $4.5 million notional wrapped BTC to USDC swap. Kind of big on size. On chains with cheaper compute, Solana, you can get complexity like this at much lower notional. And I'm about to tell you about the complexities of building those complicated swaps on a chain like Solana on the SVM that make building complicated 28 CPI swaps very, very difficult. But why 0x? We are the most powerful and accurate DEX aggregation on EVM. Matcha is our front end. It's simple, secure, efficient, and it's powered by a 0x API. We wrote Argon. I've done talks on this before, look me up. It's the leading aggregation algorithm for EVM, and it's what powers our API v2, which we are bringing to Solana. So it's not ready yet, but it will be ready soon. If you're an integrator and you're interested in bringing DEX aggregation to your users and you have opinions about what a DEX aggregation API should be, please find us afterwards. We're very ready. We're very soon going to be bringing it to you, and we want to hear about the features that you're interested in. Today's hot take: SVM is not EVM. I hope you agree with me on that one. So this is the perspective of a newly IBRL-pilled EVM dev of what does it take to port a EVM project to SVM. The call depth limit is the first stumbling block. On SVM is 4, on EVM it's 1024, with some asterisks, of course. It's not exactly those numbers. But that's not the major difficulty that we have. I'll get to the major difficulty in just a second, but let me give you an example of what a call stack might look like on EVM. This is awful. I hate this. I hate debugging this. SVM is way better about this. You can get rid of the upgradable proxies because programs are mutable. I love that. You can get rid of these because those are stupid in the first place, and the pressures on the EVM ecosystem, on the SVM ecosystem, get rid of those design patterns. And now this looks like something that's much more reasonable. We can do this for CPIs. Wonderful. I love it. But you do have to get used to the new design patterns. But the real issue is the transaction size limit, right? Solana transactions is fully encoded in a UDP packet, 1280 bytes, just the IPv6 MTU. Very important for IBRI. This limits the number of accounts that you can access in a single transaction. 32-ish for legacy transactions, 256-ish for a V0 transaction if you can do the optimal encoding, which you can't. And there's still the 64 account block limit. A DEX swap requires 8 account blocks. That gives us 8 DEX fills, very, very roughly here. It might be higher or lower depending on your DEX design. If you're a DEX designer, I want to hear from you. I have opinions about what your competitive advantage could be on 0x if you can reduce your account blocks. Moving from the description of the problem to the solutions to the problem, the SVM account model really kind of solves the problem itself. The separation of code from state. I love that. Thank you. Bush oracles, you don't have that pattern of having to call into an oracle and pull data from it, having your oracle data encoded in the transaction blob. I love that. And native proxies, of course, are no longer a thing. I think that if you're having problems with call depth, you're having a skill issue. Program harder, please. These are some major DEXs that we're integrating. 8 DEXs is, I don't know, maybe a lot of DEXs, but for comparison on SVM, one of our chains has 49 DEXs. So, program harder. Or if you don't want to program harder, you prefer that we do it, use a product. The account limit, of course, is the real sticking point. The best solution is ALTs. The second best solution is also ALTs. And the third best solution is use ALTs. Yeah. The program-owned token accounts that we've seen deployed by some of our competitors is a great solution, but then you have state contention issues, which affects inclusion rates. And the ecosystem, as we saw on the previous slide, has fewer DEXs to begin with. Fewer DEXs because the second best DEX gets no flow, because if you're at the account limit, you can't compose a multiplex of one more DEX. The interventions that we've done, the technical solutions for somebody wanting to build a DEX aggregator on SVM, biggest one is Jito bundles, multi-transaction atomicity through something like Jito, and hopefully soon in protocol bundles. Out of that. Meta transactions and intents. These are a technique where somebody else actually handles all the swapping and then sends you your tokens at the end. Another clever way of building multi-transaction swaps. And limit orders, which, hot take, is the same thing as an intent. To summarize, DEX aggregation gets you the best price every time. Your users don't want to think about having to find the best price. We find the best price for you. Doing DEX aggregation well is hard, really hard. In fact, on Solana, on SVM, the transaction account limit moves DEX aggregation into a completely different complexity class. On EVM, we know how to solve a very close approximation of the optimal route Kalman polynomial time. Solving that same problem with the account limit actually is an NP hard. So, good luck. And the impact, of course, of solving it incorrectly is NP, right? The optimal DEX route is the one that moves the market the least and moves all DEXs the same. And so if you can't touch the entire market because there's too many accounts to touch, you're going to move only part of the market and you're going to generate NAV. And any NAV that you generate, of course, is value lost by the taker. We're doing it. We're fixing it. You want to take advantage of all of our hard work, you should plug into our API. And if you're at DEX, please talk to us. And if you didn't see your name on the slide where I listed a bunch of SVM DEXs, doubly so, because we want to know about you, we want to integrate you, we want to send you flow, we want to send you fees. And lastly, if you want to connect, you want to know more about 0x, please scan the QR code. Thank you very much.